Hello, my name is Keiko Okada.
And I'm Yimtong Wang, and this is our presentation of Denny Creek sliding rocks in the Mountain Baker, Snoqualmie National Park. The cover pictures is one of the creek's waterfalls and an overview shot of the sliding rocks.
This is a map of the Snoqualmie River and tributaries that feed into it. Denny Creek is part of the South Fork that flows into the Snoqualmie River.
Now I'll explain the geological history of Denny Creek and its surrounding landscape. The Cascade is at least 400 million years old in the geologic history. There are a collection of different rock types that can be found all over the Cascades. The collection is made up of volcanic island arcs, deep ocean sediments, basaltic ocean floor, parts of old continents, and even pieces of deep subcrustal mantle of the Earth.
The assembled pieces were uplifted, eroded by streams, and then locally buried in their own eroded debris. Other pieces were forced deep into the earth to be heated and squeezed, and then raised again to our view by subduction zones, faults, and other plate tectonic activities.
In southern and central Washington, the Cascade Range is made of young volcanic rocks, ranging from 0 to about 40 million years old, that erupt from many volcanoes, forming the Cascade Volcanic Arcs. In various places near Snoqualmie Pass, the foundation of older rocks can be seen under the volcanic cover. Farther north, fewer young volcanic rocks are preserved and more of the foundation shows. Also exposed are the granitic rocks that once, as magma, invaded the foundation of older rocks that became the reservoirs of magma that filled now eroded volcanoes.
The different rock types that can be found in our area are rocks of the Cascade Magmatic Arc, which consists of QTCP, which is intrusive rocks of the Cascade family. That comprises of granodiorite, granite, and rare gabbro that crystallized between 1 and 20 million years ago. This and other intrusive rock families formed as magma crystallized beneath the volcanoes of the Cascade Magmatic Arc. Another rock type is TCAS, intrusive rocks of Snoqualmie family, similar to the rocks of the Cascade Pass family, but crystallized between 22 and 28 million years ago. Another one is TKEB, rocks of Eastern Melange Belt, mostly mafic volcanic rocks and chert with subordinate sandstone and foliated sandstone, argillite, philitic argillite, and marble. And the last one is QU, unconsolidated deposits, non-glacial, alluvium, which are valley bottom sand and gravel in small streams, hill slope debris, wind-blown debris, soil alluvial fans, and landslide debris.
This is a Google Earth screenshot of Denny Creek. As you can see, the creek is situated in the middle of the V-shaped valley, suggesting the glacial movement in a slight downhill slope. There are also horns, artes, and coals that can be seen in the upper left-hand side of the photo.
Here is a photo of the Denny Creek trail map. We wanted to see more, but we only made it a little bit past the Alpine Lake Wilderness border to see the famous sliding rocks.
Here is an overview shot on the sliding rocks and some families enjoying the beautiful summer day at the natural water slides. The slide is weathered since the rivers, streams, and fords are functioning in Denny Creek. It shows that the site is eroding by these forces. Moreover, the streams transport the sediments, rocks, and the boulders to the bottom of the river. This forms the deposition smooths and polishes the rocks, giving it well-round shape.
This is one of the first things we noticed when we arrived at the sliding rocks. This is a synplutonic dike that was made when molten basalt is infused into the cracks and fractures in mushy granodiorite. The basalt crystallizes immediately, forming a dike, but the granodiorite was still mushy and moving about, breaking the dike into several pieces.
Here is a picture of some slabs of rocks that have been scarred with striations by a moving glacier carrying debris.
We also found some xenoliths within the granodiorite slabs. The picture on the right is about 4 inches long.
Here are some pictures of signs of weathering. The rock on the left shows red rusty lines suggesting iron oxidation and striations from past glacial movement. And the picture on the right shows that the sign of intrusive failure, which is formed when blocks of solid surrounding rocks were ripped off from the walls and sediments together with each other surrounding rocks by a fine-grained matrix.
Here are our sketches. The first one is an overview sketch of the creek, and the second one is a sketch of granite and diorite rocks.
Thank you.
Thank you.
Any questions?